Now we are interested to find the differential length in case of a spherical coordinate system. For that purpose we have considered the part of the sphere, and now we make this is the radius of the sphere and this is the projection of that at the xy plane. A small angular displacement in the xy plane is made, that is d phi, and a small angular displacement in case of theta is done here. So this displacement is reflected here, like that, and this displacement is reflected here, like that. This is the differential object. Suppose the part of the radius is considered this one. This is the object, differential object considered to find the differential length. Projection of this will be here, like that. Another marker is not working properly, so I am unable to draw it clearly. So this is the differential object for which we are interested to find the differential length, surface and volume. So in this case, just name the differential object A, B, C, D, E, F and G. To find the differential length, just take the maximum possible length displaced by this object, that we can assume it can be AD. So AD will be equal to the AB, BC plus CD. AB plus BC plus CD. And we know that the increasing direction of any vector is considered as the direction of unit vector. So this is the small radius dr, and the direction of dr will be this one. So AB can be written as, AB is changing in this direction, so AB can be written as dr in the direction of r, plus BC can be written as, see, this is the arc, this is the arc, this is the same arc. So arc can be, if it is a small angle displacement, that is d theta, then this can be this radius with d theta. You can say radius is projection of this at xy plane, that is rho. So it will be rho d theta, rho d phi. If this angle is d phi, the arc will be rho d phi, that is very small, if d phi is very small, and rho d phi, that will be equal to this rho d phi, and it will be rho d phi. So BC can be written as rho d phi, and the direction of this phi is changing in this direction, so it is a phi direction. So BC is this one, that is direction of a phi. BC is in the direction of a phi, moving at the surface, tangent to the surface. and CD can be the moment of displacement, it is due to the displacement d theta. So this will be in the direction of a theta, and the displacement will be this radius with the angular displacement. So this is r, this is d theta, so this will be r d theta in the direction of a theta. So everything is known from here. Rho, we can say from the previous derivation, we found that rho is r sine theta. So dr ar r sine theta d phi in the direction of a phi plus radius of the sphere d theta a theta. So now AD is differential length that can be written like that. So the proper writing in proper sequence, you can say dr in the direction of r, r d theta in the direction of a theta plus r sine theta d phi in the direction of a phi. This is differential length. Now this is x, y, z. The cross product of these two will give third one, and cross product of these two will give third one. Similarly, the cross product of r and theta will give the third unit vector, because these three are orthogonal. D a phi is normal to the surface from parallel to the xy plane, and a phi is normal to the surface from normal to the surface and tangential to the a phi, and ar is normal to the plane. So in this way all are orthogonal. In this way the differential length we came to know. After that, if we wish to find the differential surface, then there is no need to find the surfaces and find the differential surface for all 6 surfaces. Just what you have to do, multiply these two and the cross product of these two. dr r d theta ar a theta will give you a phi. So you can write r dr d theta a phi, and ds can be written as multiplication of these two, r square sine theta d theta d phi, and cross product of these will give you ar, because we know ar a theta a phi. The product of these two will give you ar, and a theta will give you a phi. Theta and phi will give you ar, this and give you a theta. In this way we can find the ds, the third one. That will be r dr sine theta sine d phi and a theta. Just I multiplied these two and the cross product of these two, that becomes this one. Multiply this and cross product of these two will give you this one. Multiply this and cross product of this and this will give you this one. In this way differential surface can be found out. Now differential volume is important for us now. Differential volume can be multiplication of all these coefficients is in scalar form. So dr or d theta or sine theta and d phi, including all, you can say r square, dr, d theta and sine theta, d phi. This is differential volume. In this way, in the case of spherical coordinate system, we find out differential length, differential surfaces and differential volume for this differential object. Now let's summarize our discussion. First thing that we discussed, a rectangular coordinate system in which the coordinates were x, y and z. The second thing was cylindrical coordinate system in which coordinates were radius, that is represented with rho, phi, azimuth angle, z. Third thing that we discussed was spherical coordinate system, and that was the variables in this case was radius of a sphere, the angular position from z axis and from x axis in xy plane. And further we studied the transformation from rectangular to cylindrical and cylindrical to rectangular. After that we discussed the transformation from rectangular to spherical and spherical to rectangular. Additionally, we discussed the three important parameters, that was differential object analysis, differential length, surface and volume in case of all three coordinates. So we have discussed these things until now, and that is it for today, and next turn we will discuss about differential operators. Thank you very much.